kind of have an explanation what is harmonic motion, and so it's like a repeated movement. If you think about a spring with a weight attached to the end, okay? If you pull that spring down and let go, what happens? It goes back up, and then does it stop? No, it keeps bouncing up, back and forth, right? Yep, like a bungee cord. So that could be modeled with a sine or cosine function. Any type of wave pattern, you know, even if you're watching like a dolphin, the way it goes above and below the water, okay, those can be modeled with our trig function. Waves, sound waves, waves with water, those kinds of things. And so it's oscillating around this equilibrium position. When we're talking about simple harmonic motion, we are just talking about the basics of how we could model this with a sine or cosine graph. And you would pick whether it was sine or cosine based on your starting point. Most of the time for us, you know, if you're thinking about pulling a spring, did it start at its center if you had to stretch that spring out? No. So that would be modeled by a cosine graph. If it's going to start at its center, that would be a sine graph. So in this, just like with our graphing, the amplitude is just your coefficient. So our amplitude is A. Period, just like before, sine, cosine, normal period is 2 pi divided by the number in front of x. Here, typically, instead of x's, we see t because it's in terms of time. So it's just 2 pi divided by the number in front of t. So 2 pi over omega. The other thing that we haven't talked about yet is frequency. So period is how long it takes until it repeats itself. The frequency is reciprocal of that. So it's going to just be your period flipped. So it's basically, the period is how long it takes to make one complete cycle. The frequency would be like saying how much of a cycle do you complete each second. Okay, so if my period is 2, then I could say, okay, it would take me 2 seconds to make one complete period. The frequency would be 1/2. So in 1 second, I've done half of my period. All right, so let's see if we can model some. Suppose an object is attached to a coiled spring. It is pulled down 5 inches from its equilibrium and then released. The time for one complete oscillation is 4 seconds. So a lot of times we use S of t. That's the same thing as saying y. It's just your position at time t. Is this a sine or a cosine graph? Sine has to start at its center. Okay, so we had our spring, but did it start at its center? I pulled it down 5, and then it started bouncing back and forth. So if I started down, this would be a cosine. Cosine normally starts up high, so what would be true about this cosine? It's flipped. What is the amplitude of this? 5. We started 5 below the starting point. So we already know it's a -5 cosine. And that's because the amplitude here was my 5. The down told me that we are flipping. The time for one oscillation is 4 seconds. That's the period. Okay, period is found by doing 2 pi divided by the number in front of t, or omega is the notation they're using here. So 2 pi over omega equals 4. So 2 pi equals 4 omega, divide by 4 and we get pi over 2. Yeah, it looks a little different because we're using omega and t, but it's the same idea. So my equation is -5 cosine of pi over 2t. determine the position at 1.5 seconds. So I am just asking you to plug this in. And let's just use a calculator to get our approximation. We need to make sure we're in radian mode because the pi is definitely radians. So we have -5 cosine over 2 times 1.5. And I get 3.54 inches. Make sure you're in radian mode.
Yeah, I'm probably typing.
It's okay. Don't do the high. All right. So what that's telling me, it's a positive, so that means it's above the center. So this is 3.14 above right now. So you're thinking about the graph, it's kind of right here. You know, it's on its way up to hit my max, or potentially over here on its way back down. Find the frequency. Frequency is the new thing. It's just the reciprocal of the period. So if my period was 4, that means my frequency would be 1/4. And that's oscillations per second. So we make 1/4 of a cycle every second. We're 1/4 of the way through. Any questions there? Let's look at it. So if this is my equation, I just want to describe its movement. So basically, I want to describe the amplitude, period, and frequency. All right. Does this one start at the center or a higher low point? Where does sine start? At the center. Is this flipped or anything? No. So what it's doing is it's starting at my center and going up and just back and forth. What is my amplitude here? 8. So what that means is it travels 8 feet above and below the center. Period. What's the period of this? 2 pi over 3. In terms of motion, it might make more sense to not even have it in terms of pi. If you actually divide that, you get about 2.1. So what that means is it completes a cycle in about 2.1 seconds. Frequency is just the reciprocal of period. So this would be 3 over 2 pi. Okay, so if you divide those, you get about 0.48. So it makes about 0.48 oscillations per second. So in 1 second, it's not quite halfway through. It's questions there? Let's start it from another equation. A weight on a spring has an initial position S of 0 equals 2 and a period of 0.5 seconds. S of 0 equals 2. That means when my time is 0, this is currently at a height of 2. Does that sound like a sine or a cosine? Where does sine start? Sine starts at the center, which is 0. Is this the center? No. So this is going to be a cosine graph. This is going to be traveling like this. Okay, so if I want my equation, I know it's a cosine. What is my amplitude? Was this one flipped or anything? No, because we started at the high point. Alright, so now we have to figure out what goes here. So the period is 0.5 seconds. So 2 pi over omega equals 0.5. Divided by 0.5, so you get omega equals 4 pi. So it's 2 cosine of 4 pi t. That's our equation. Alright, B. Evaluate S of 1. You plug in a 1. What do you get? Cosine of 4 pi, so cosine of 2 pi. That's 1, and then multiply by 2, we should get 2. Is the weight moving up or down when t equals 1? So, think about this picture with a pen drew rough sketch. I told you the period was 0.5 seconds, right? So the period is how long it takes until it makes one cycle. So here, this is 0.5 seconds. Make another cycle, that's 1 second. We're right here. We're at this peak. Is it moving up or down at the time, or is it in between? It's in between. It is changing from up to down. So after 1 second, if you just think about the graph, you would have traveled up to the top of that graph, and now we're getting ready to fall back down. See, when does it hit its maximum height? Think about this graph. Cosine starts and stops at its maximum height. So we started at the maximum. When's the next time we hit that max? At 0.5 seconds, and then again at 1 second, and 1.5 seconds. So, yeah, I'm going to say every 0.5 seconds we hit that maximum height again. One more. A note on the piano has a frequency 27.5. The maximum displacement, so that's like saying the furthest you get from the center, happens S of 0 equals 0.21. Write the equation. S of 0, so at time 0, we are at a height of 0.21. Is this a sine or a cosine function? Cosine. Most of these will be cosine because something has to start the movement. Okay, and usually that starts by stretching or something like that. So most of these would be a cosine. What's my amplitude? 0.21. It's not flipped. So now we have to figure out this angle. So I give you the frequency. If the frequency is 27.5, then that means my period is 1 over that, right? Because I told you they're reciprocals. So think about how we find period. 2 pi over omega equals 1 over 27.5. Let's multiply. Omega is 55 pi. So this is 0.21 cosine of 55 pi. So really all we're doing on these is writing equations. Any issues with that? So I'm done. Only 5 problems. Number 6, it says to draw a graph, you do not have to